In this section, we'll look at proving cofunction identities. We now have the ability to prove the cofunction identities. As a reminder, the cofunction identities for radians for cosine and sine are that the cosine of an angle t is equal to the sine of the quantity of pi over 2 minus t, or the sine of an angle t is equal to the cosine of the quantity pi over 2 minus t. Let's take a look at an example where we're being asked to verify these identities. The first one says to verify that the cosine of t is equal to the sine of pi over 2 minus t. We will need the difference identity for sine in order to rewrite the right-hand side to try and get it to equal the left-hand side. All right, so my identity deals with the sine of alpha minus beta. So in this one, we're going to let pi over 2 be my alpha, and we'll let t be my beta. So we can set this right-hand side equal to the sine of that first angle, which is pi over 2, times the cosine of the second angle, which is t, minus the cosine of the first angle, pi over 2, times the sine of the second angle, which is t. Okay, what is the sine of pi over 2? The sine of pi over 2 is 1. We don't know anything about the cosine of t, so we'll leave that alone. The cosine of pi over 2 is 0, and we don't know anything about the sine of t. Simplifying this, we get on the right-hand side 1 times the cosine of t, which is just cosine of t, and then 0 times anything, of course, is 0. So we have proven that the right-hand side turns into cosine of t, which is what the left-hand side said. So that side has been proven. Now let's do the same thing, but for the sine function. In order to prove that the sine of t is equal to the cosine of the quantity pi over 2 minus t, we need the difference formula for cosine to rewrite the right-hand side. Like we saw before, we're going to let pi over 2 be our alpha and t be our beta. And we'll rewrite that right-hand side as the cosine of pi over 2 times the cosine of t plus the sine of pi over 2 times the sine of t. Okay. Cosine of pi over 2, we said that was equal to 0. Still is. Cosine of t, we don't know what that is. Sine of pi over 2 is 1, and we'll multiply that by the sine of t. So 0 times anything wipes out. And so on the right-hand side, I'm left with 1 times the sine of t, which is just the sine of t. We have that on the right, and sure enough, that is what we wanted on the left to prove this identity. Now, does this work for any angle measures? As we mentioned before, this is true for complementary angles that add to 90 degrees or pi over 2. Now, because those angles add to 90 degrees or pi over 2, those angles are acute angles, meaning less than 90 degrees.